Hi, my name is Jake Rita, and this is my mechatronics project for the fall of 2015. We're going to call this video the current state of affairs. So everything's not quite done, but I'm going to walk you through what I do have done and the idea of how everything is going to function in the end, hopefully in a couple days. So starting with the mechanical part of it, there's a tea hopper. This is going to store all the tea. Has an easily take up removable lid. There's chambers in the top here. You'll be able to drop a tea bag after you remove the string right into one of those, and that'll keep it relatively fresh. It's a closed container. Driving this, we have a stepper motor down here. It is connected to a wooden shaft right now. It's a little off center, so there's some induced friction, and that causes changes in velocity as this moves around. As this does rotate though, it'll come around to this area right here where there's an opening, and the tea bag will be shaken so that it'll drop. Ideally it'll drop. We're still working on this part. Right down this little ramp right here. And once it's in there, we're going to have a relay turn on the 120 volt power to our glorified hot water heater. It's really just a really cheap coffee maker that now just boils water and pours it on top. And after the water has boiled, everything will be turned off, and boom, you have tea. But the special thing about this whole setup, I mean, why would I go through the trouble of setting up a whole flat pack thing here with all these components put together, is the fact that it's controlled by the internet. So this is going to be controlled in real time with a Teensy, which is this microcontroller here. I'll bring this in closer for a better view of the electronics. So this is kind of a custom built board right now. Here we have our Teensy right here, which is currently connected to the desktop computer here. And right here is our stepper driver in this kind of mess of patch wires. This big large thing is a capacitor, which is going to be filtering the signal from our 12 volt in. Just to clean it up a little bit. This big guy here is a relay, which is going to use the signal from a MOSFET, which will be plugged into this port here, which is controlled again by the Teensy to turn on and off our 120 volt power to the boiler. And so that will all be hooked up in the future. We can go ahead and plug in the power supply and check out how well this thing actually turns, because it does actually turn pretty well. You can see the shaking motion. That's going to be to help get the tea bag out, because it's not a perfect fit. Probably could have done to make the chambers a little bit bigger. Yep, you can see it's getting stuck right there. So we're going to have to work on that in the future. Alright, now we're going to talk about the internet connectivity a little bit. So to give you a basic idea, here is the website that is going to be hosting everything. Real simple, just a press button. Currently not completely functional, and it just kind of gives you an error. This is due to some conflicts in our web server right here, which is actually a Raspberry Pi that's going to be running everything. You can see on the left hand screen is our HTML code. This is kind of what dictates the button that you saw on the screen, all the things that you see, and it points any actions on the web page to certain scripts or functions. On the right hand is the PHP. Now these are both files within a certain folder driven by an Apache web server on the Raspberry Pi. Within here, we think we have some permission conflicts and possible ownership conflicts that will not allow us to execute the file from the web page. The file is actually hosted on the Raspberry Pi, which is running through the local Mechatronics Wi-Fi, and the web page that I was clicking on the computer is actually connected to the Lehigh Wi-Fi. So they are two separate networks in essence. So we need to make sure that we can get communication between the two of them. But the PHP basically opens up a file, which it calls in this top line right here. And if it exists, or doesn't exist, it gives us this error. If it can't open it, it gives us this error. And we're getting the can't open error. So we know the file exists, but for some reason we can't open it. Down here we have a section, and this is the writing to the file. It's going to write a certain variable to the file and then close it. From here we have Python running on here. It's a little Python script, and the Python script is what's going to help us communicate through serial. Right here you can see it's starting out serial with the Teensy, which is going to be hooked into one of the USB ports for the Raspberry Pi. So the Python is going to open up our file that we modified with the PHP, and it's going to put that file, take the readings from that file, concatenate it into a string, which it can then send over serial. Before we do that, we add an H to it. So we know that this specific command being sent through serial is coming from this specific Python code. Kind of gives it a uniqueness to prevent it from reading other stuff instead. And then through the Teensy code, I'll show that back over here on this computer. Just been still doing some editing. In here we have all kinds of things declared as variables and such, but we've learned about that before. The important thing is going to be how we read through serial. All the values are going to come in as a string. We're going to take those values and turn them into variables and assign them. And if a certain variable is set to 1 or 0, then it's going to execute some of these void statements down here, essentially functions. And I would like to get it to actually, after all this has been completed, write back to serial, back to the Python, back into the HTML, and print out, hey, your T is done. So that's the gist. We just got to get there. There's a couple little roadblocks in the way and some work to be done on the system. We're going to replace this wooden rod here with a nice aluminum one, so everything spins really freely. We won't get those variations in velocity. Then we can run it a lot faster and get it to shake the tea bag out a little bit better. And that's about it. Thanks.